Hello, Internet. Today we are going to try and play with PyCompiled / compiled, which is a compiled version of the Python standard library. This should replace pure Python implementations of the standard library, as I understand that. And we are going to figure out if that is actually working. I have not tested this library yet, and it might be a huge failure, and we'll hopefully see that it's not. So let's call that library right now. So right, compiled and sync. So this should be installing quite quickly. And if we probably also want to add another dependency, or we don't even need that probably. So how does that look like? So we install that usage. We'll install PyCompile CLI script as well. Okay, good to know. And we just import things regularly, the rest of our code, and then we run pycompile on ASD, and then it just replaces the imports. So we don't have to use the pycompile executable. We can just let ourselves just import directly from the compiled library. But it is like kind of a nice thing. Local development and testing, we don't need that because we're not going to develop and test this, but it is good to know that this is what they do. By the way, this is an actual fork of CPython, which means they actually try to keep that in line with the actual standard library as it's being implemented, which is kind of nice of them. Anyhow, let's actually give that a shot. So first of all, let's open PyCharm with that, and we can also activate our virtual env, which Python. Yep. Okay. So we are definitely within this Python. By the way, we can now run this and import compiled. Yeah, and we have compiled got all the standard libraries that are supported. And as we can see, we've got APIs here, like replace imports and all sorts of stuff. Okay, so interesting things. So we can quit our CLI and go fetch ourselves some code. So let's run something interesting here. So from which part of the standard library is, let's say, slow? We can see what they suggest here. So they are passing some toml and they are importing difflib. Interesting. So difflib is actually interesting, but also I haven't had a lot of experience with difflib, so I don't think it's good to explore that. But we can literally try to pass the PyProject toml file, and let's figure out if that is actually faster or slower. So from toml-lib import level style. So we've got load. So let's go with loads. Actually, let's just import toml-lib, and in our hello, let's introspect into. Also, let's go for pathlib. So import pathlib, or from pathlib import path, and we can go for PyProject path, and that should be let's see, parent, then PyProject toml. Yeah, that should be fine. And we can now, first of all, let's just read the text. And once we've got that, let's pass that. So it's loads. Could have given it the file pointer itself. Maybe we should have done that. But I want to actually test the performance of that. So let's just do that in a loop. So for I in range this thing, and we also might want to like add some progress bars on that, so we will have a feel to how fast that is. So let's actually do that. So try add tqdm, try sync. Let's let that run in the background, and from tqdm import tqdm, let's wrap that loop with our thing. And now that we've got that, we don't need to return because we're not planning to return anything. And okay, so this has happened. The import is working. So we've got ourselves a nice thing that actually tests the performance of this parser. And let's just have like a small benchmark. So we can go for hyperfine dash. Let's warm up any disk caches or anything like that. So let's just run that like one warm-up run, and then we can go for Python, and we like to basically just directly run compile the stdlib under init, and if under name equals main, run hello. Yeah. Okay, so this is like a baseline measurement. And that won't work because what we want to is run that. So that is taking so little, I'm quite surprised. No way this is actually happening in 48 milliseconds. It is. Wow. This is pulsing quickly AF. Just to be sure, yeah, let's just go for like 10,000 iterations. So it's 20K iterations per second. 20,000, yeah, 20K iterations per second. So let's just go one more iteration. Yeah, so we're still in 22,000 iterations per second, but now we're actually like giving it something to work on. So, okay, now we can actually let that run, and we'll have ourselves a stable benchmark, and then we can actually measure against the compiled version. Let's see if we've got a performance improvement. So here we've got the estimate of like 4.5 seconds. And in a minute, hopefully, we will learn if the actual compiled thing is better than that. Yeah, I guess there's no need for a warm-up for that thing because well, it's a really tight and hot loop. By the way, this is basically only measuring the parsing performance because I hope we're not generating any garbage except for the parser itself right now. Like we could have maybe, I don't know, like not used DQDM and then might be a little bit faster. Let's just have that as a measurement. Let's see if the overhead of actually measuring an individual run is not like hurting us too much. Oh, but now we don't have our info. So let's just find that quickly. So start, pause, time, performance, perf counter, and perf counter. And let's just go with loads took. Yeah, so let's divide our n here. N equals this thing, and average start, yeah, end per start. So this is supposed to be, let's actually inverse that because we want to know how many passes per second. So that's our rate. Loads per second. Yeah, okay. So now without TQDM, yeah, so 22K is not affected by the actual loads logic by the TQDM thing. That this is like not an important overhead. Just to be sure. So 22 434 versus 22,200. Okay, so we are having a really small amount of overhead. Let's just make sure that's not like actual noise. Okay, so it's within like noise. So yeah, we can just continue forward. This is less than 1% measurement error for the noise of TQDM, the noise that TQDM adds to the measurement. Anyhow, now that we've done that, let's actually import from compile.tomlib as tomlib. And let's measure it first by hand. And it is, wow, okay, it is actually faster. And let's just run that with Hyperfine and let's figure out if it's actually faster now. So compared to our previous tests, here we've got 3.34 seconds mean, and here we've got 4.5. So the parser is significantly faster, like in the sense that if there are no risks of it being different, then I would basically just, it's an easy import if you've got like a performance issue with the standard library. So that's kind of nice. I wonder if they have, I don't know, a compatible ether tools, compiled ether tools? No ether tools. So do they only have tomlib and difflib? That's kind of sad. I was certain they had more modules, replaceable modules. Tomlib, difflib. That's kind of a shame. I was thinking this was a more mature project. Now I see we're only having like this small subset. So first of all, I'm glad that I went with their example, but also like this is still like okay. So this is not useful for me now because I don't use difflib or tomlib in like any of my actual projects. But this replace import is useful, and then it's the CLI. Okay, so very basic, but it is working. So they have successfully compiled tomlib and difflib to be faster. We're not going to actually test the difflib as well because, well, I think they have wasted our time a little bit. But hopefully we should try ourselves to actually, I think maybe I'll do a follow-up video where I actually test their method and actually try to compile my own type-safe code with mypyc, and let's see if it's actually faster and easy to compile. So tune in for the next video. It might be about compiling Python to faster Python. See you in the next video.